Okay, let's look at this pendulum. We can see that the pendulum bob at position 1 and position 2, they are at the maximum height. Okay, so at the maximum height means that they have the maximum gravitational potential energy. And at position 3, the height is at the minimum. So that means that the gravitational energy must have been converted to kinetic energy. So the kinetic energy is at the maximum. Okay, now let's look at the question. The question asks, where does the ball have the most kinetic energy? So we know that the answer must be at position 3. So is it the first time it passes through position 3, or is it the last time? In this case, it has to be the first time, because as it swings for the first time, second time and the third time, it will lose energy to the surrounding. So the total energy will be lesser, and the kinetic energy at position 3 will be lesser as well as time goes by. Okay, to calculate the average power developed by the girl, we can use the formula power is equal to work done over time. So the work done by the girl is actually the work done against her weight. So her weight is 500 Newton. So the work done is equal to force times distance. She has to apply a force of 500 Newton to overcome her weight. And as she climbs up the stairs, she's actually moving 5 meters along the direction of her weight. So the distance, it has to be 5 meters. And the total work done will be 2500 joules. And now we come back to this power formula. Power is equal to 2500 divided by the time taken, which is 10 seconds. So that will be 250 watts. Answer C. Okay, to find the pressure that this brick exerts on the ground, we can take the force divided by the area. And the force of this block, it will be the weight, which is 80 Newton, and the area will be the area in contact with the ground. So it will be this area, which is equal to 10 cm times 5 cm. So it will be 10 times 5. So the answer should be C. Okay, this is a manometer. So what we can do is to draw a horizontal dotted line across here. So we know that the pressure above this dotted line on the left is equal to the pressure above this dotted line on the right. So the pressure down here, it will be just the pressure of the gas. Let's denote it as P subscript G. And the pressure on the left above the dotted line, it will be the pressure of 8 cm of water plus the pressure of the atmospheric pressure. So in short, the pressure of the gas is actually equal to the pressure, the atmospheric pressure plus the pressure of 8 cm water column. Okay, so now let's look at the option. Okay, the pressure of the gas in this case, can also be interpreted as 8 cm of water more than the atmospheric pressure. So the answer should be A. Okay, this is an example of a Brownian motion. So what we are seeing under the microscope is the smoke particle, because the air molecules, they are too small to be seen. Okay, so what can we deduce from this random motion is that the smoke particle, they are moving in random motion like this is because they are constantly bombarded by the air molecules, which are also moving at random. So the answer should be B.